Okay, this is topic 1 on describing motion. We already went over this the other day, but I'm not sure if I posted this, so I'm just going to review it here. It says average speed, so we're talking about motion. Our first thing we talk about is speed. So one way to describe the motion of an object is to compare the total distance it has traveled to the time required to travel that distance. This comparison is known as an object's average speed. So we use this formula here. V is equal to delta D over delta T. That delta I wrote over here means the change. So our change in distance over our change in time. And in the yellow here, I've got written down the units that we would use for speed. So for us, we would use kilometers an hour. So this is the one that we would use in Canada. And this one would be something that you would use in the US. Okay? No, that's not right at all, sorry. I'm looking at that as miles, but it's actually meters per second. This is the one that we would use in the USA, miles per hour. So USA. And then M over S means meters per second. And this is the one that we would use normally in science. So when we're talking about certain things happening outside of like a car, we would measure in meters per second, like the speed of light, the speed of sound, all those sort of things would be measured in meters per second. So on the next slide, we'll try some of those out. So for all of this, for calculating the average speed, we are going to use the formula right up here. So V is equal to D over T. And then really we're just plugging in the pieces of information we have in our question. The first question says a cyclist travels a distance of 40 kilometers over a period of 2.5 hours. What is its average speed? So the very first thing I've got circled there in the green is our average, our distance. So our distance, it literally says that. So for D, I put 40. And then right here is our time, 2.5 hours. So we put that as our T. We've got a D over T, so we're looking for our V. So we plug that into our formula, 40 divided by 2.5. And I've got the answer here is 16 kilometers per hour. I don't think I had enough room to write per hour, but it should be per hour. Okay. The second one here, a cheetah runs at an average speed of 80 kilometers an hour. So it's telling us that's our speed. So that would be our V, 80 kilometers an hour. If the cheetah runs for a period of 0.15 hours, how far does it travel? So our time is 0.15 hours. Then we need to plug into this formula. We put our 80 where V is. We don't know what our D is, and then we do that. We can... Did I not finish this question? I think I didn't finish this question right here. So and I'm going to do that. We've plugged it into our formula. Basically, what we've got to do, I'm going to just move that over so we can calculate it right here. So 80 is equal to D over 0.15. So for this, I would just multiply or cross multiply. So we could cross multiply this times this, and that'll give us the answer for that. So if we go 80 times 0.15, we should get an answer. And I don't have a calculator, so just 1 second. Do this out on your calculator. You should get 120. And that is our distance, so that would be 120 kilometers. All right. The third one here, we've got this really spaced out. I think it's because I was going to do the calculation elsewhere. But I will erase it and we'll redo it right here. So it says a taxi drives a distance of 298 kilometers. So it's telling us right in the question our distance is 298. This is from Calgary to Edmonton if the taxi travels at an average speed of 110 kilometers an hour. So it's telling us our speed, which is our V, is 110. How long will it take them to reach their destination? So we're looking for our time. So if we plug this into our formula, V is equal to, wow, distance over time. Our V is 110 is equal to our D, which is 298 divided by our T, which is our time. Excuse me. So then we get we can calculate this out. Our first step is to move that T up. We don't want the T to be on the bottom, so to do that, we would multiply both sides by T. Alright, so that, we really don't have enough room here. So I'm just going to erase this. So when I multiply both sides by T, I'll have the 110T is equal to 298. Okay, so then I can just divide both sides by 110, and that'll give me what T is. Okay, so when I do that, that'll get rid of that, so T is equal to whatever 298 divided by 110 is. I get 2.71. That would be hours. So 2.71 hours it takes to drive from Calgary to Edmonton. So that seems pretty accurate if we're thinking about it in our life. If you've ever drove from Calgary to Edmonton, that's a pretty realistic distance. Alright, moving on. So uniform motion. It says average speed is an easy way of assessing an object's overall motion. However, it does not always accurately reflect how an object's motion has changed. Uniform motion, or the movement of an object in a straight line at a consistent speed, is rare in nature. Objects tend to speed up, slow down, change direction. This change in speed or direction is called non-uniform motion. So basically what it's saying here, in real life, we don't really have uniform motion. Our motion is definitely more non-uniform, but it's there is possibly some things in life that could be uniform. Maybe like throwing a ball up in the air or something. But we will get to that. It says which object below displays uniform motion. So the one that would be uniform motion should be the same distance over the same time. So uniform motion would be object B. Okay. See how object A is changing? It's got a curve to it, so that's going to make it non-uniform. Okay. Speed limits. It says vehicles do not typically travel with uniform motion, except for on long, straight highways. What then are speed limits referring to? Rather than referring to average speed, speed limits actually indicate that speed that you should be traveling at that instant in time. This is known as instantaneous speed. So speed limits are looking at what is your speed at an exact moment. And that's the moment, if you're looking at when you're speeding, when the cops use the radar to basically figure out what your speed is at the exact moment. So it's not worried about if you're going at constant speed, but what are you going in that moment. Scalar quantities. It says scalar quantities are average speed is an example of one. Scalar quantities are measurements that do not include direction. Time and volume are other examples of scalar quantities. So a scalar quantity, there's no time. No time or direction. So an example of you saying an average speed is an example of a scalar quantity, okay? Why did I say no time? Sorry. Scalar quantities are literally not, they can be time, they just have no direction. So they're not telling you the place they're going. So if I say I'm going 110 kilometers an hour, well, you have no idea where I'm going. You have no idea the direction. So that's definitely an example of a scalar quantity. Also, they're saying down here that time and volume are other scalar quantities. So if I told you it took me like 2 hours, you're not telling you any sort of direction. A volume, I don't know why we would use volume in this case, so I'm not going to write a volume, but we'll move on. Although highway speed limits are understood to be a measurement of kilometers an hour, in Canada, average speed can also be measured in meters per second. To convert from meters per second to kilometers an hour, it is important to recall that 1 kilometer contains 1,000 meters, and 1 hour contains 3,600 seconds.